Everyone. Today we are starting chapter 12, and chapter 12 is all about similar figures, scales, proportions, and size changes. And we also call those size transformations, and as you can see, we're starting that one today. This one actually is two different parts. One is going to be the physical size change, and the other one will be all about circles on a graph. So today we're going to start out with that physical size change. Now you can see I already have something down from last time. It's a bit of a messy sketch, but just as a reminder, when we do size change, we talk about it with an S sub K. Sub meaning it's just below the normal line in a text, kind of like when we do X1 or X2. And here the S stands for a transformation of size change, and K stands for the magnitude of that size change, magnitude just being how big or small it grows or shrinks. So when I say I want a size change of magnitude 2, what I'm saying is I want to grow this figure to be twice as big as it was. Now, size changes we've done before in a graph, and all it takes is multiplying your coordinates by that number for your size change. But here I don't have a graph, so that means I'm going to have to do a size change in a different way. So let's see how that works. When you start your size change, what I want you to do is make sure that you have this center point drawn on your paper, and I do actually want you to do this one for our lesson today. The next thing I want you to do is draw a small figure, make it like maybe no bigger than your thumb like the instructions here say, and try to use straight lines with easy to connect points. It will just save you some time. In fact, you can keep it very simple and just do a triangle or a square or some sort of trapezoid so that it's going to be easier to get those lines connected and have your end figure. Now, what I did first with my size change is I started with my protractor ruler. You can use any ruler to do this, of course. And I just measured the distance between my center and one of my points on my figure. Doesn't matter which one. Please, when you're doing this, be very careful that you're actually on the center and make sure that when you're doing your measurements, you're dealing with probably centimeters rather than inches. Centimeters are easier to multiply to get a nice answer since inches don't have what we call base 10. They don't go up by tens. You're going to get some kind of weird math there. However, if you like using a different what we call base, go for it. I think it's kind of fun and it's a little bit of a game for your mind. But centimeters will be easier. So I'm doing this in centimeters. So I measured this first distance. I found it's 1.4 centimeters. Well, I want a size change of magnitude 2. And that means I'm going to actually double the distance between my point and the center. So I went and I lined it up. Notice it has to be on this same line. And I went double the distance, which was double 1.4 or 2.8 centimeters. And that brings me all the way to 2.8, which is this point here. Now I'm going to repeat this process, finding the distance between my center point and another point on my figure. And here I find that this is 1 centimeter away. I'm going to go double that, or 2 centimeters. See how you don't have to write out every time like the whole 1.4 or 2.8. That's just for the illustration purposes. And it's totally fine if your new figure intersects or overlaps your older figure. Depending on how close you are to the center, that's more likely or less likely to happen. Mine lines up perfectly. Yours might have a huge gap between the two images. It just depends. Now, I'm going to do this with every single point on my figure and just one by one dropping them into their new locations. So again, 1.2 about here will become 2.43, somewhere in between those, giving me this as my next point. It's very close to my other point that I just found, which makes sense because you can see that these two should be pretty close together. And I end up with something that looks a little bit like that. I'm just going to thicken it because my original is thickened. So I'm going to quick fill in the rest of my figure. Please do the same on your piece of paper. So there is my figure, and yes, it's an approximation. The more points that you transfer over, the more accurate it will be. So I basically did the outline and I did a central location on this, and that gave me my end result of my new piece of pizza. But or upside down party hat, I don't know what that is. Anyways, but what you guys can do is go really slowly, really carefully, and you can get actually really accurate pictures like this. Like take any printed picture offline, and you can do this, make it larger or smaller by hand, and get some really fun and cool results while practicing being an artist using basically only math. So just measure very carefully. Now, there's some interesting patterns that go on with size change when we do it this way. First off, notice how most of my lines, and in fact it should be all of my lines, are parallel to their original line. So if I'm looking at this line here in its original line, you can see that these two are parallel. And you could see the same thing with this one and this one, and even these two here. Now, is there some inaccuracy? Yes. I'm using imperfect tools and I'm probably going a bit faster than I should, but you can find that general pattern that these will end up being parallel. Aside from that, I did not at any point measure the length between here and here. In fact, I just drew the points and I dropped the new length in there. But this is a measurement of about 1.6. And when I measured the corresponding point, I have like 3.1. So almost double. And here, if I measure the distance between here and here, I've got about 1.3 or 4, so 1.35 about. And from here to here, I've got looks like about 2.6. So notice how each of these are getting doubled. In fact, they should be exactly doubled, but again, there's some inaccuracy. Now, you could continue to grow this figure. I could grow my original figure by a multitude of 3, and that would mean I'd take this distance, I'd multiply it by 3, I'd drop that third point around here, or maybe 5, or 2.1, or something like that, to get entirely new figures that are 3 times, or 2 times, or 3.5, or whatever you pick times as big. And go ahead and play around with that a little bit. Turns out there is a pattern here. When we're talking about K as our size change, it has some interesting pieces of information about it. First off, if we're talking about a K that is greater than 1, an absolute value of K, remember absolute value just takes off the negative. So if we're talking about a -2, it would become just a size change of 2. We'll talk about what that negative does in a little bit. If you're talking about a 2 here, it's going to be called an expansion. An expansion, because it's growing larger or expanding. If K is between 0 and 1 when we take its absolute value, so we're basically talking about like things like 3/4 or 0.1. If it's between 0 and 1, it's going to be what we call a contraction. So in this case, it is shrinking. So anytime you talk about contractions, just be aware of that. It's talking about a decimal figure that is between 0 and 1. Now, when I talk about negatives here, negative just talks about direction. So usually we're going to just kind of like pick a direction. If you have specific coordinates with it, that negative might send it the opposite way of what you're expecting. So rather than sending it in this direction, I'd literally go exactly opposite of it, and I'd go up and to the left instead of down and to the right. But that is a different time that we're going to worry about that. What we're going to do is we're going to find the center in magnitude of our transformations. So let's say that I took these smileys and I shrunk down this one. This is what we call our pre-image, and this is our image, the thing that came after. And it does matter which one is which. If I want to find its center, all I need to do is find some corresponding points. So see in this figure where the corner of its mouth hits. It's a very nice, neat point. I'm going to take the corner of the mouth here that corresponds. So this is the same point, just moved and translated over. What I'm going to do is I'm going to connect those 2 points, these corresponding points, And I'm going to do so as precisely as I can. I'm going to be very careful that I'm not like moving things around or hitting at an imprecise location. And I'm going to try to extend it in both directions. The next thing that I'm going to do is I'm going to find another corresponding point. Try to pick something that's a fair distance away, but still has that very distinct point, and connect those two. Now what you'll notice is that one side is getting wider and wider, and one side is getting smaller and smaller. The side that's getting smaller is getting closer and closer to that center point, that center of your size change. And since we want to find the center, that's the point that we want to find. And you should always do this with at least 3 points, because that's going to show you that you actually found the right one and you didn't bump your ruler too much. If you use less than 3, if you're using like 2 of them to find that, a lot of times it gets off. So see how even this, it's not quite all hitting at the same spot. That's that margin of error that we're dealing with. The more points that you do this connection with, the more accurate your final answer will be, because you'll have more data to work with. And it looks like this about is my center. It's where all those points come together. Aside from that, I also want to find its magnitude, and you can do this one of 2 ways. Your magnitude can be found by finding what your proportion is between your center and your pre-image and your center and your image, or you can measure the corresponding lengths of things inside of your figure. So for instance, I could measure the length of the smile here versus the length of the smile here. I'm going to use my center to do this, but it is up to you how you want to do that. So here, let's just measure this way, where I have between this point and my center, I have about 5.8. And again, your answers might be slightly different than mine. So this is with my pre-image. And with my second one, what I'm going to have is the distance between that same point, that corresponding point, and my center, which is at about 3.9. If you want to find your K, what you're going to do is you're going to take the image number and divide it by the pre-image. That will give you K. So I can take 3.9 divided by 5.8, and that will give me my here contraction, because if this is my starting figure and I got to this one, I should end up with a smaller answer. If you get those two ever mixed up, just flip your fraction. So if you did this whole thing and you're like, wait, I got an answer that's like 3.4 and it's supposed to be shrinking, it just means that you switched image and pre-image here. Just find the reciprocal of it and you'll have your answer. But of course, if you do image over pre-image, it will always be correct. So let's find what that is. We've got 3.9 divided by 5.8, giving us an answer of about 0.6724 for mine. Now yours, of course, this measurement is an approximation, so don't worry if you're just slightly off from that. I'm going to do this once more though, because just like with these lines, there's some issues that can come with precision here. So I'm going to find another one, and let's just use the corner of the mouth here. And that gives me a 4.8. Wow, I got a lot of 0.8s here. And again, I'm careful that I know what I'm dealing with the pre-image and not the image. And over here, I should have an answer close to that. I've got like 3.1-ish. And dividing my image by my pre-image, I'm going to take 3.1 divided by 4.8. Giving me another answer, which is about 6 or 0.6458. The more of these that you get, the more accurate your final result will be. So I could take these two numbers, my 6.458 plus my 0.6724, and take the average of those divided by 2, And that will give me my average size change, or a more likely precise size change of 0.6591. And the more information you get, the more accurate that final answer will be.